Hello, Year 11s. Welcome to the next lesson, 14L. We're dealing with the tangent function at the moment. Okay, so we've graphed sine and cos at the moment. We're graphing the tangent function. So remember that the tangent function represents the gradient. Okay, of both our sine and cos. Okay, so remember that our gradient is rise over run. Okay, and this becomes sine theta over cos theta. Okay, so we need to get that formula in our mind to see what the tan function looks like. Okay, so this here is what the tan function looks like. It looks pretty crazy. It's very different to what the sine and cos were. Okay, the sine and cos were almost identical. They would just translate a little bit horizontally to have a little bit of separation. Okay, so what we have is we need to think about these lines. Okay, we've got some asymptotes. Okay, so asymptotes at some different locations. Okay, so where I've drawn that. Why do we have the asymptotes there? Okay, so what you need to do is again think about our sine theta over cos theta. These are the locations where the cos theta is actually 0. So remember that you can't divide a function, so you can't any number divided by 0. So if cos is 0, you can't divide that function. That's why we get the asymptote. Now if you notice that, remember that you get cos is 0 at pi on 2, 3 pi on 2, 5 pi on 2. Because if we draw a unit circle, okay, up the top, okay, so we'll go back. If I draw the unit circle, cos represents a horizontal displacement, okay, and remember at pi over 2 and 3 pi over 2, the horizontal displacement is 0, okay. So that's how we get our asymptotes, because of the cos function, okay. We get our x-intercepts, okay. These intercepts that we have there when sine is 0. Okay, so if sine is 0, the whole function will be 0, and that's how we get our intercepts. Okay, so again, if I draw my unit circle across here, okay, so remember that we're going to have sine is 0 at 0. Okay, and that represents our first intercept. Sine is 0 at next at pi, which is there. Okay, because remember it represents a vertical distance. Remember, so there's no vertical distance, and as we rotate around, we get 2 pi. So if you notice the pattern, it goes from 0 pi, 2 pi, it's going to go 3 pi, 4 pi, 5 pi, 6 pi, and there's going to be that repeating pattern. Okay, so this is what I've explained about everything in the green box. Okay, so the lines, those ones there are the asymptotes. Okay, so negative pi on 2, pi on 2, 3 pi on 2, and 5 pi on 2. Those are the asymptotes because of the cos. That's when cos is 0. The x-axis intercepts occur when sine equals 0. Okay. So when 0 pi, 2 pi, in general, if we're trying to find any values, so, it's just k of pi. So if we want to find the first intercept, okay, we just put 1 into it, so we get 1 pi, which is located there. We put 2 into it, 2 pi, and so on. Okay, so we'll start dealing with these repeated pattern and these repeated pattern formulas. Okay. And as you can see, that our gradient is going to constantly increase, but never actually reach the asymptote. Okay, and that's part of the reason why we get those values. Okay. So observations. Okay, so what do we notice with that y equals tan? That's the same graph as what we had on the other side. Okay, so the graph repeats itself every pi units. Okay, so the period is pi. Okay, so remember, if we have our function. Okay, so for the time that it takes to go from up, across, and up, that distance right there, from there to there, is our period. Essentially, the distance between our asymptotes. Okay, so the distance between our asymptotes is actually our period. The range is all real numbers. Okay, so remember that this is very different to the sine and cos. Remember with the sine and cos, the domain was all real numbers. In this case, tan is all real numbers. Okay. The equations of the asymptotes can be found using this. Okay. So 2k plus 1 pi on 2. Okay, where k is an integer. K is just a number that we want to find. So if we want to find the first asymptote, we just put the number 1. If we want to find the second asymptote, we put 2, and so on. Okay. So we're just constantly repeating that pattern. Okay. What happens when we get some dilation? Okay, so we get some dilation from the y-axis. so from the x-axis, sorry. Okay, and then that end represents dilation from the y-axis. Okay, so that changes how far the period is. Okay, so if it gets wider or closer together, and then the A changes if it gets bigger or smaller. Okay, so remember that. So what we've got is the period. We can actually calculate the period. So remember how we said for the standard tan function, the period is pi. When we have a different value, okay, so when it's been dilated from the y-axis, we can find the period as pi divided by n. So very similar to the 2 pi over n with our sine and cos, just marginally different with this one. The range is all real numbers, which I spoke about before. That hasn't changed. The asymptotes have equations, so the exact same formulas we had before, except in the denominator, we've got the value of n. Okay, so we're finding that if it has been dilated, we're going to generate a certain amount of values. And then the x-intercepts are these ones. Okay, so we're in k pi over n. Okay, so we get the formulas for the asymptotes, formulas for the x-intercepts, and it's generally reasonably easy once you find these to draw our tan function. Okay, so we've got an example here to sketch the graph of y equals 3 tan of 2 of x. Okay, so what we're going to do is we're going to find a few things. Okay, the first thing we're going to find is our period. Okay, period is equal to pi divided by n. The value of n is 2. Remember the n's inside the bracket, so that is pi over 2. Okay, we can't simplify that any further. That's what we've got. The next one is we've got our asymptotes. Okay, so this formula is so 2k plus 1, okay, pi divided by 2n. Oh, sorry, divided by 2n. Okay, in this case, n is 2. Okay, so this becomes 2k plus 1 pi over 2 times 2, 4. Okay, so that's our formula for our asymptote. Okay, so to find our axis-intercepts, okay, so we're going to use the formula that we had on the previous slide. Which was k pi over n. In this case, n, as we know, is 2. Okay, so these are our 3 values that we need to generate with. Okay, so what we're going to do is we're going to generate all our values within this domain. Okay, so x is an element of negative pi to positive pi. Okay, so as I change color, I'm going to start to draw my y-axis. Okay, next axis. Okay, so hopefully everyone's using a ruler, unlike me. Okay, so what we're going to do is we're going to generate the values between pi and negative pi. Okay, so what I'm going to do is I'm going to break this up into sections. Okay, so that's going to be pi over 2. Break it in half again, so pi over 4. And that'll be 3 pi over 4. Just to help me draw it, okay, it's going to be make it a bit easier if I break it into sections. This one, that'll be negative pi over 2. Here we get negative pi on 4. And here we've got negative 3 pi on 4. Okay, so to generate some of our values. Okay, so our period is pi on 2. Okay, so remember that we haven't had any translation, okay, so it hasn't moved left or right. The dilation has moved left or right, okay, but our initial value is still 0. Okay, so we're actually starting at that location there. What we've got is that period is actually pi on 2. Okay, so what we do is, because we're pi on 2, remember that this is our, so it's sort of flowing up and through, so the whole distance between these 2 points must be pi on 2. And what you'll find is that our first asymptote will actually be pi on 4. Okay, what we can do is use this formula to generate it. Okay, so if I'm going to let k equals 1, so for my asymptote, I'm going to go 2 times 1 plus 1 pi over 4 times 1 is 2 plus 1 is 3, so you get 3 pi on 4. Okay, so that one over there is what we have. Okay, so that's an asymptote. If I put 0 into this, Okay, so if I try and do find another asymptote, so 2 times 0 plus 1 pi over 4, okay, which equals pi on 4. Okay, so as you can notice that is my 2 asymptotes that I've got there. If I want to go back one, okay, instead of putting 1, I can put instead of putting 0, so I can put -1. So 2 times -1. Didn't need to put a bracket there. Bear with me. Okay, plus 1 over pi over 4. Wants to draw, yep, there we go, it's a little bit slow. 2 times -1 is -2 plus 1. So that becomes -1 pi, so -pi over 4. So this is my other asymptote. So as you notice that you can just generate your values. So if you start with the number 1, okay, it's going to give you one of the asymptotes. And then if you want to find any asymptotes before that, just reduce the value that you're putting in. Okay, so just reduce up. Instead of the 1, we're putting in 0, and then we go -1. Okay, so then the last one I'm going to put in -2. But what I will know is by now you should be able to see the pattern. Okay, because we know the period is pi on 2. Okay, the period is pi on 2. That's the differences between these asymptotes. Okay, so we're constantly adding pi on 2 or we're subtracting pi on 2 depending which direction we're going. Okay, to find out axis intercepts, okay, so what I'm going to do is I'm just going to swing my head to the top. I might use a different color for this. So I might use, we'll go green. Okay, so if we're going to deal with our axis intercepts, I'm going to try that again. There's a little button on this pen that's really annoying. Okay, so if I go back to my green, so we got the intercepts. Okay, we're going to follow this formula. Okay, so k pi over 2. So I'm just going to put 1. So 1 pi over 2. And that's one of my intercepts, which I can find is right there. Okay, what I want to do is I want to find the next one. I could do 2 pi over 2. So 2 pi over 2, which equals pi. And that's my next point there. Okay, so what you can see is you can see a pattern. And the intercepts are always going to be, as long as there's no vertical translation, okay, they're always going to be sort of symmetrical, okay, in between the two. So what we've got is as you put the values in, so we do 0 pi and 2 would give us that one. So we put -1 into the formula, we get pi, okay. So just increase or decrease the value depending on what values that we need to generate. Okay, now that we've got quite a bit of information, we've got our asymptotes, we've got our intercept, and what we do know is it's a positive tan. Okay, so we know the slope that this graph is working on. Okay, so if I move down, I'm going to change color again. I'm going to go to, I've got a blue again just to help me draw it. Okay, so what we're going to do is we're going to draw this. Okay, so what you'll find is this first one at -pi, because it's got a positive slope, it's going to go, it's going to go there all the way up. Okay, continue on. Make sure that you're not getting those lines to touch each other, asymptote or the line. Okay, as we go up, we're going through the intercept and graphing up. Okay, please make sure that this isn't just a straight line. Okay, you need to show the shape. If you do this, if you don't show the shape in a SAC, or an exam, you'll be losing marks. Okay, so please try and take some bit of care as we're drawing our way through. Okay, and what you notice is that is everything that we have. Because we're including, okay, these last n bits, okay, what I'm going to do is, there you go, I'm going to include it, okay, because we've got the square brackets. So if that was not including, I'll put a little open bracket there, okay, but I'm including those values, so that's everything that I got there. Okay, so that's how to graph a tan function. Okay, I've got a couple of other examples in the next video, so please just hold on 2 seconds while your teacher changes that. Okay, thank you.